Hello guys, welcome to join our session today. I'd like to continue the lesson of continuity. In this lesson, as usual, every lesson we need some skill that we learned before or that we gained before from the previous year. I'd like to know how to find the domain of any given function. Here, determine the number at which the function has a discontinuity. I have to read the question, what I want from this question. Find the values of x at which the function has a discontinuity. Look here. For problem number 1, I have to know, I discussed the continuity on the entire real number line, as you see here. That is number 4 because I have two rules. Okay, one of them, when x not equal 4, it means greater than 4 or less than 4. So the function I will substitute in function 1, okay, when x less than or greater than 4, it will be 5 over x minus 4. I replace in this one. When x not equal 4, okay, here 5 over x minus 4. But when x, here negative infinity, and here infinity, that is the entire number line, okay? Here it will be 2, f of x, it will be 2 when x equal to the function equal 2. Please, miss, what is the rule I have to follow? I have to know, the first step, what is the domain of the given function 5 over x minus 4? The domain of this function x not equal 4. The domain of any rational function, it will be all of the real number except the value of x at which the denominator equal what? 0. But miss, since I substitute in this function when x not equal 4, it means less or greater, so this function is what? Defined. And as you know, any function continuous on its entire domain. Entire what domain? So this function continuous, because this function defined for any value less than or greater than 4 or not equal 4 by any way. This function also, its domain x not equal 4, but all of these value which greater than 4, the function is what? Continuous, because the function defined on this. The rest value of the real number which I have to discuss the continuity at it is at x equal 4. Okay, since all of the values less than 4, the function continuous because the function defined on this interval. Here, for all of the values greater than 4, the function also continuous. What I write in blue, it means that the explanation of the concept. Understand? But green, that is my mechanism. But I wanted from you to understand the concept and the mechanism of solution. Since this function is continuous at every real number, okay, because it's a domain. But here I have to discuss the continuity when x equal 4. At x equal 4, I have to discuss the continuity. I have to know the function continuous or discontinuous. I have to follow how many steps? 3 steps. Maybe I will not continue if one of them not satisfy. The first one, I have to find f of 4. I have to find the value of the function at this value of x, which means x equal 4, so the function equal what? 2. Okay? Here, find limit f of x when x approaches to 2 from left. From left, it means, 2 or 4, sorry, I'm so sorry, for this one, 4, I'm sorry, 4, from left. It means I have to substitute here, no, because when x approaches to 4 from left, it means less than, okay? by another way, not equal 4. Approaches to 4, but not equal 4. So I have to replace in rule number 1. Because when x not equal 4, I have to substitute here. When x approaches from left or approaches from right, I replace in rule number 1. Okay, here it will be 5, replace in it. 4 minus 4, it will be 5 over what? 0. So limit does not exist. Okay, I will not continue. Why, miss? Because since the limit from left does not exist, so the limit does not exist. In this case, I told you the function continuous if it satisfies at any value of x, if satisfies 3 conditions. The function defined, it is already defined and equal to. The limit exists, the second condition, limit exists, and the limit equal the value of function. Since is the second condition here not satisfied, so here f of x, this is continuous. Discontinuous at x equal what? X equal 4. In this case, I discuss the continuity everywhere on the real number. Okay? Here, before 4, after 4, or less than 4, the value is less than 4, the value is greater than 4, the function continuous, because the function defined when x not equal what? 4. This means for all of the real number, the function continuous, except number 4, I have to discuss at it by following my steps. Since the limit does not exist, so the second condition, okay, not satisfied, so the function discontinuous at x equal what? 4. Okay, here. For question number 4, I have to follow the same way. I have to draw the number line for me because sometime I ask you write the interval on which is a function continuous. Okay, I follow the same steps. Look with me. For question number 2, I'll draw the number line as you see here. Okay. Here I have how many rule? I have 3 rule, less than 3, at 3, greater than 3. So here I write the 3 which I defined the function by different way before it, at it, and after it. When x less than, here negative infinity, and here what? Infinity. X less than, it means at its left. The function x squared minus 9. At 3, it will be 3. Okay, that is first rule. Second rule, when x equals 3, here 9 minus x to power 2, when x greater than 3. Okay? You have to know what is the domain of this polynomial function. It is what? All real number. So this function defined for all of the values less than 3. This function defined on all real number, but here it's subdomain what? X defined on what? X less than 3. So this function continuous. Why? Because any polynomial function, its domain or real number. But here I define this function on the given what? Subdomain or subset of real number, so it will be continuous. The same 9 minus x to power 2, it is a polynomial. It is what? Continuous, because it is a polynomial function. And any function continuous on its entire domain. Okay? Here, miss, what is the rest of the number line? I have to discuss the continuity at number 3, because all of the values less than 3, the function continuous. All of the value greater than 3, the function continuous. Why? Because it is what? Polynomial. In this case, I have to discuss the continuity at x equals 3. At x equal what? 3. At x equal 3. I have to find what? F of 3 by the same way. Second step, limit f of x. When x approaches to 3 from left, I have to, by the same way, find the value of the function at this value of x, limit from left. Third step, limit of f of x when x approaches to what? 3 from right. Here, f of 3, I have to replace in the rule at which x equal. So it will be this rule, it will be 3. Okay, limit f of x when x approaches from left here, from left x less than, it will be what? 3 square minus 9, it will be 0. Limit, but miss, as you see, the limit from left not equal the value of the function. The limit from left as the limit from right add the value of the function to be continuous. Here it will be what? 9 minus 3 to power 2 equal what? 0 also. Okay, as you see here, the limit exists because limit from right as the limit from left, but not equal the value of the function. Or by another way, here the value of the function must be equal to limit from right and the limit from left. In this case, since this condition not satisfies, so f of x is this continuous at x equal what? 3. Because he asked me, determine the number at which the function has a discontinuity. X equals 3, the function not continuous or discontinuous. I think it's so easy. You can begin from here. You can discuss the continuity at the value of x. We define 3 or define the different rule of this function. But please, please focus. I have to understand. When I discuss the continuity of any function, I have to discuss it on all of the real number. Okay? It's very, very important. Here I have only value at which I define 3 different rules for the function. Understand? Before, after, and at it. Clear or not clear? Okay, grade 12, please focus. Try to understand the concept. I have to discuss the continuity on all of the real number. Here, let's please try to pause the video and solve number 3 alone. Then check your answer from me. Okay, look with me here. I think it's so trivial. In this case, I define the rule before -2, okay, and after -2 or less than 2, greater than 2, less than, -2, less than -2, greater than -2, and by this way. I have how many points? I have to draw the number line for me to understand. That is negative infinity, that is what? Infinite. Here I have -2, here I have 2. The function here I replace in this rule when x less than -2, I replace here 6 plus x, and if it is equal, and if it is equal, I replace in this rule. Clear? Here the same, if the value of x between -2 and 2, I replace in this rule, and if it is equal also what? I replace here if it is equal also 2. X greater than 2 only, 2x minus 1. Okay? Here, this function is what? Polynomial, so it is continuous. This function here, polynomial, and what is its domain? Its domain here, all real number. But here I ask you, this function defined on this interval? Yes, so it will be continuous. Since it is polynomial and I know it is defined on all of the real number greater than 2, here what? Continuous. Clear? So what are the real number? I have to discuss the continuity at it, at -2 and at what? 2. By the same way I told you before, at x equal -2, how many steps? 3 steps, as I told you in my session. Okay, at x equal to, I have to discuss the continuity. What are my steps? F of -2, find the value of the function. Limit f of x when x approaches -2 from left. Limit f of x when x approaches to -2 from right. Okay, f of negative 2, which rule I have to substitute? I have to substitute in the rule at which we have equal with negative 2. This one I have to replace here. So it will be 6 plus negative 2, it will be 4. Limit from left, it means when x less than, so I replace also in this rule, less than. 6 plus negative 2, it will be also what? 4. From right, it's clear from right, I have to replace of the rule such that x greater than negative 2, it will be what? 2 minus negative 2, it will be 4. Since the value of the function as the limit from left and the limit from right, so f of x is continuous. At x equal what? Negative 2. Okay, so up to now I didn't find any value of x at which is the function discontinuous. I have to discuss the continuity at what? At x equal 2. By the same way, okay, step 1, no, different color, please. Step 1, step 2, step what? 3. Step 1, f of 2. Replace in the rule at which we have equal. So it will be 2 minus 2, it will be 0. I replace in this rule. Limit f of x when x approaches to what? 2 from left. Limit f of x when x approaches to 2 from right. From left, it means the less than, from left, less than 2. It will be 2 minus 2, it will be 0. From right, I have to replace greater than, so that is from right, that is left of 2, understand? It will be 2 multiply 2 minus 1, it will be 3. They are not equal. The limit, the value of the function not equal the limit from right and the limit from left. In this case, I have to write what? Look in different color. That is my answer. That is my answer. I'm sorry. F, this function f of x is this continuous at x equal what? 2. That is my answer. That is the value of x at which is a function discontinuous. I hope you understand. But I need the skills of how to find the domain of any function. Try to understand and prepare any questions that you would like to ask the next session. Thank you. Bye-bye.